In this lecture video, we are going to discuss about parameters and arguments, fruitful functions and void functions, and why we need functions. Some of the built-in functions we have seen required arguments. For example, when you call math.sin, you pass a number as an argument. For example, math.sin of 45 degree. So interpreter will give the sin 45 values. Some function take a more than argument. For example, maths.power. It takes a 2. The one value is base and another value is exponent. For example, so here power of 2 comma 3. So here 2 is the base value and exponent is 3, and the result is 2 to the power 3. So here the inside the function, the arguments are assigned to a variable is called a parameter. So here 2 comma 3 is the parameter, and here sin 45 is the parameter. So here is an example of the user defined function that takes on an argument. So here this is a user defined function definition def. This is a keyword for function definition, and function name is print underscore twice, and argument is Bruce. So this is the argument. So inside the function we declare the arguments. So this it acts as a parameter. Now we are going to print Bruce and print Bruce. So it's going to print the parameter in twice. This function is assigned the argument to a parameter named Bruce. When the function is called, it prints the value of the parameter, whatever it is. It's twice. The function works with any value that can be printed. If you call this function print underscore twice Bruce, so it will print the Bruce twice. So let's call the function. The function name is print underscore twice. The argument is spam. So first print statement is print spam, and second print statement is print spam. So here the interpreter is going to print the spam and spam in twice. 2 times it's going to print. So let's consider one more example. Function name is print underscore twice. The argument or parameter is 17. The resulting output is 17 and 17. So let's consider one more example. So here we are import the mathematical model, then we call the function. The function name is print underscore twice. The parameter is math.pi. So math.pi is a constant value. The pi value is 3.14. The interpreter is going to print 3.14 and 3.14 in 2 times. The sum of the rule of the composition that applied to a built-in function also apply to user-defined functions. So we can use any kind of expression as an argument for print underscore twice. So for example, print underscore twice spam star 4. So here spam is going to print 4 times twice. So this is the first time, and number of spams are 4, and this is the second time, and number of spams are 4. Let's consider one more example. Function name is print underscore twice the maths dot cos math dot pi. So this is the argument or parameter. It's going to print minus 1.0. The argument is evaluated before the function is called. So in the examples, the expression spam star 4 and maths dot cos of maths dot pi are only evaluated once. You can also use a variable as an arguments. Let's consider one more example. Here, the Michel is the variable. The assigned value is assigned string is rec the of a b. So this we assign to variable and variable name is Michel. So here we call the function. The function name is print underscore twice and this is the variable Michel. So here it's going to print the assigned string. The assigned string is Eric, the of a b is going to print twice. The name of the variable we pass as an argument is Michel has nothing to do with the name of the parameter Bruce. It does not matter what the value was called back home in a caller. The print underscore twice. So we call everybody as brew. So let's execute all these things in interpreter.
So here, df is the keyword. So function name is print underscore twice and argument or parameter is Bruce. The first print statement is Bruce and second print statement is Bruce. So we have two printing statements. This is the first printing statement and this is the second printing statement. So here we call the function. The function name is print underscore twice. So this is the function name. Here we call the function name and argument is Bruce. Just you observe the indentation. So this is the indentation and here we define the user defined function. So print statement 1 and print statement 2 is belongs to function definition. So here we call the function Bruce. So it's going to print twice. So just you run this code. So it's going to print Bruce and Bruce twice. Again you call the function, same function. The function name is print underscore twice spam. So here print underscore twice is the function name. The task of this function is to print the argument in two times. So let's execute this. The interpreter is going to print spam and spam twice. So again you call the function. The function name is print underscore twice and here we are giving integer values. 17 is the integer value. Just you run this. So interpreter is going to print 17 and 17 twice. Now you import mathematical model MAT. Now you print, you call the function. The function name is print underscore twice and argument or parameter is maths dot pi. The pi is the inbuilt function, mathematical inbuilt function. The pi value is 3.14. So just you run this. So interpreter is going to print 3.14 and 3.14 in 2 times. Let's consider one more example. So here we assigned Michelle is equal to Eric, comma, the of a B. So this is the string, and Michelle is the variable name. So Eric the of a B we assign to Michelle. So now you call the function name. The function name is print underscore twice. So this is the user defined function. This is the header, and function name is print underscore twice. Now now you call the variable name. The variable name is Michelle. So now you run this. So interpreter is going to print the assigned value. The assigned value for Michelle is Eric. The of a B is going to print 2 times.
Now we will look into fruitful functions. What are the fruitful functions and void functions in Python? Some of the functions we are using, such as a math functions, eats the result. The math functions are the built-in functions. For a lack of better names, I call them as a fruitful functions. Other functions like print underscore twice, what we declared in previous examples, perform any actions but do not return the values they called void functions. When you call a fruitful function, you almost always want to do something with the result. For example, you might assign it to a variable or use it as a part of an expression. So for example, here x is equal to maths.cosradian. So it will give the result. For example, let's consider one more variable, golden is equal to square root of 5 plus 1 by 2. So here this is the expression we assign to variable, and variable name is golden. The here maths dot square root of 5 will gives the square root of 5 value. It's equal to 2.23 plus 1. The resulting value is 3.23 whole divided by 2. So it will give the result. When you call the function in interactive mode, the Python is displays the result. So for example, maths dot square root of 5. So this is the interactive mode. So it will gives the result. The result is 2.23. The square root of 5 is 2.23. But in a script, if you call a fruitful function and do not store the result of the function in a variable, the return value is vanishes into a mist. For example, maths.square of 5. This script is computes the square root of 5, but since it does not store the result in a variable or displays the result, it is not very useful. The void function might display something on the screen or have some other effects, but they don't have return values. If you try to assign the result to a variable, you get a special value called none. So for example, you take result is the variable name, it's equal to print underscore twice Bing. So Bing is the argument, so it's going to print Bing and Bing 2 times. So here print result. So if you print the result is the variable name, so it will gives the none. The value none is not the same as the string none. It is a special value that has its own type. So for example, print of type none, the class is none type. If you want to return the result from the function, we use the return statement in our functions. For example, we could make a very simple function called a odd2 that add two numbers together and return results. So let's consider one specific example. Here we declare one user defined function. So this is the header. So def add 2 a comma b. So add2 is the function name, def is the function keyword, and a comma b are the parameters or arguments. So here the function is added. So added is equal to a plus b. Added is equal to a plus b. Here we call the return function return to added. Return to added. So here we declare one more statement. X is the variable name. X is equal to add2. So this is the add2 is the function name. Add2 is the function name. Add2 of 3 comma 5. So 3 is equal to a and 5 is equal to b. 5 is equal to b. So if you print x, so x stored value of add 2 of 3 comma 5, the stored value is 5 plus 3 8. So 8 is stored in x. If you print x, the output will be 8. So when this script executes, the print statement will be print 8 because the add2 function was called with 3 and 5 as an argument. So here 3 and 5 as an argument within the functions. The parameter a and b were 3 and 5 respectively. The function computed the sum of the two numbers and placed it in the local functions variable named added. Then it is used to return the statement to send the computed value back to a calling code as the function results, so which was assigned to a variable x and printed out. So if you print x, we will get 8. So here we call the return. So it's return to added, and here we assign the values, and values are 3 and 5. The result of this is stored in x. If you print x, you will get the stored value. The stored value is 8 when a is 3 and b is 5. Now we will see why we need functions in Python programming. It may not be clear why it is worth the trouble to divide a program into a functions. There are several reasons. The first reason is creating a new function gives you an opportunity to name a group of statements, which makes your program easier to read, understanding and debugging. Function can make a programs smaller by eliminating the respective code. Later, if you make a change, you only have to make it is one place. Dividing a long program into a functions allows you to debug the part one at a time and then assemble them into a working whole. Well-designed functions are often useful for many programs. One, Once you write and debug once, you can reuse it. The main advantages of the function, it reduces the length of the code and reusability. These two are the main advantages of the functions.
These are some references. Thank you.